the embodiment is essential to our understanding of the human mind. So before I start, I would just like to point out that I will here touch only a couple of aspects, or I will just go through some of the venues which leads to the realization that the human mind is embodied. So this is one. So I will leave a lot of things out. The other thing, if you're familiar with the embodied cognition literature, different perspectives, theories, and so on, you will notice here that I'm leaving out certain aspects that are perhaps more close to the classical view on cognition, and I'm emphasizing some others that are closer to the enactivist view on human cognition, and so forth. But of course, this will demand a couple of sessions to really go into depth. But here, what I will try to show you, for instance, is that because this is what we will be dealing with in the next part of this webinar and in the next week also partly, is that thinking processes or thinking itself is not in fact what classical cognitive science believed, and further on, the mind is not, and there are many different theories and research showing that, so that the human mind is not some form of abstract information processing device similar to a computer, but for it, what is essential is the human body in this or that understanding of the human body. Firstly, I will be very brief on this. So I would just want to give you one of the main ideas of classical cognitive science. So this is kind of how the human mind was seen in the 60s, 70s, 80s. Of course, not by everybody, that has to be said, but a majority kind of the atmosphere in cognitive science. So the mind was seen as a computational and representational system of which one of the main tasks is to transform inputs, for example, sensory signals, so this would be stimuli, into outputs, so into behavior, into certain bodily actions. And this was done according to certain formal procedures, and thus the human mind is kind of seen as a device that processes information from some perspectives. So what is emphasized here is not how the agent, so the body, the whole system, takes in stimuli and how it responds. What was emphasized was basically mental processes and later on brain processes. And from this, as I will try to show, many from this presupposition, this metaphor of the human mind working as a computer, for instance, what happens is that many essential things for the human mind, for the workings of the human mind, are neglected. And we will see some examples of research that, well, show that this is simply wrong, that the human mind is a kind of an abstract processing device, so to say. This is one of the seminal papers by Liddy and Lustard on how human beings and also then how computers should and do create medical diagnosis. Okay, it's a very old paper, so much has been done on this field. So, but the point is that what they wanted to do here in this paper is they wanted to take this metaphor of the human mind as a computer and wanted to take the tools of symbolic logic, probability calculus, value theory, and so on, to also understand how the human mind makes diagnosis, and also to be able then to implement this into a computer. So here on the left, you can see a little example of a part of the process of making a diagnosis as they kind of extract it from their view on how doctors do medical diagnosis and what is close to a computer system. So here, for example, what happens, they would say, how we reason is that if a patient has disease 2, then symptoms, then he must have symptoms 1. If the patient has symptoms X and epsilon, then he must have had this or that disease with that probability, and so on. And this is an illustration, of course, but this is kind of how processing information according to certain formal procedures, functions, and so on. This is how the mind approximately was seen, and a computer was not just an aid to human thinking, but it was a kind of a simulation of human thinking. It wanted to be. Of course, as we will see, in many examples, this is not how the human mind works. And this last, I quite like this right scan of the Flores and Vinograd's book, Understanding of Computers and Cognition. Urban reminded me of this years ago, and it's quite interesting to see that Flores and Vinograd, they quote certain authors from the 80s and 70s. They're very optimistic in what in the future, near future, machines and computers will achieve. And for example, they would say in 5 or 6 years, by 1988 or thereabouts, so this is like 35 years ago, portable quasi-human brains made of silicon will be commonplace. And they continue later on that we will carry these small creatures, now they are already creatures, with us everywhere. They will be R2s, D2s without wills, brilliant but nice personalities, and notice there are persons already, never sarcastic, always giving you a straight answer, little electronic friends that can solve all your problems. Because computers, will get faster, more capable, with more, bigger hard drives, and of course we already kind of know at least the basis of how, the human intelligence works, and we just need to implement it in these computers. And one of the very interesting examples of this idea with which you can play it with at home is a kind of a first prototype of a AI psychotherapist called Eliza, which was based almost purely on if-then rules, drawing from lists of sentences and possible answers to your queries or reports on your trauma or your experience of, being dissatisfied with life. And you can try it out on this website. It's quite funny. And of course, this doesn't work in this way. The human mind doesn't work in this way. And of course, if you look at various chatbot industries and so on, there hasn't been a, really good psychotherapist designed based on these studies, an AI psychotherapist. And this has a lot to do with the fact, I think, that this view of the human mind as a computer is is strongly flawed, because it leaves out so much that is important for the human mind. This is my brief entry into how the classical cognitive science approximately saw the workings of the human mind or cognition. So human mind was thought was kind of a device, a kind of a system that transforms inputs into outputs by processing information, by doing computations and so forth. The last slide on this is very telling. So Howard Gardner, in his book, The Mind's New Science from 1985, and this book is one of the first, if not the first, history of cognitive science. And he very clearly states certain features of cognitive science, one of which is, he says, the deliberate decision to de-emphasize certain factors, which may be important for cognitive functioning, but whose inclusion at this point would unnecessarily complicate the cognitive scientific enterprise. And these factors would be affective, factors, processes, emotions, cultural factors, background context, and so forth. So, of course, there is so much research showing that this is also the aspects of the human mind that need to be studied. And I will try to show you, and this will be relevant for our topic of thinking and so forth, is that basically these factors are not only factors as Howard Gardner terms them. These, for example, emotions are or affective states and processes, and thus also and also bodily states and processes are essential to what we think, are essential to, for example, how we understand meaning of concepts and so forth. So these are not just factors. And another thing that is interesting here, there is no mention of the body, of course. It is not emphasized. If you read even a textbook on cognitive science that is published now, it at least mentions, and it goes into the influence and the role of the body of constituting, cognition. So very interestingly, very soon after so I'm simplifying this historic perspective here, of course. So very soon after, 1980s and somewhere in the 1990s, a lot of different evidence started popping up showing that, well, this focus on purely rational, higher order, as sometimes they're called, cognitive processes, such as decision making, problem solving, and so on, is misleading the whole conceptualization of the human mind. And secondly, what was becoming more and more clear in the 90s, for example, and on, is that these so-called lower cognitive processes, such as emotions, volitions, I mean, they were called lower some decades ago, are actually essential to some higher cognitive processes, such as decision making. And a great example, there are many examples of this, but a great example of this is decision making. So Antonio Damasio, you might have heard of him. He's a very famous neuroscientist that wrote a couple of books on decision making and emotions and consciousness and so on. Reports in some of his papers and books on this anecdote that happened to him, or I mean this story that unfolded in his life as a physician. And he said he presents this very famous patient, Elliot, that had to have an operation because of a tumor, and during this operation they damaged or removed one part of the or a lot of parts of the ventral medial prefrontal cortex. We know that this part of the frontal lobe is very much involved in emotions, emotional responses, processing emotions, and so forth. And this Elliot seemed a little bit strange. So he had some problems in everyday life, and well, he seemed to have certain problems and reported on them to Antonio Damasio. And then he gave him a battery of neuropsychological tests, and he found out, curiously, that these tests did not encounter any anomalies, so to say. So his perception, learning, memory, language, math abilities, and so forth appeared, according to these tests, quite intact. Although he had problems in his everyday life, he reported, and this anecdote is very telling what these problems were about. So once, and I'm now inventing this story a little bit, but the core of it is the same. So once he came into Antonio Damasio's office to talk about how the operation went, and to discuss the troubles and how to solve them and so forth. And at the end, Antonio Damasio asked Elliot whether he would like to arrange the next meeting on Wednesday noon or on Friday 9 a.m. And this is a very simple choice. Usually, it must be said, this is a very simple choice. I look at my calendar, I say, well, I'm free, I don't care, I want to get rid of this appointment. Wednesday is the date. Let's meet on Wednesday. That's it. It's not, there is not much usually deliberation about it. However, Elliot could not choose between these two simple alternatives. So Damasio describes he was deliberating about pros and cons of choosing this or that date, and Damasio kind of was astounded how this is possible and left him for like half an hour or so. And then, of course, he at the end, after the half hour, proposed a date to this patient. So the point of this anecdote and this patient is that this brain area, among others, is very much responsible for processing emotions, and Antonio Damasio argues that this is one of the cases that show that emotions are essential for advantageous choice, or emotions are essential for such choice where it is for such simple choices in a way. So what happened to Elliot is that one part of the brain that is essential for emotions was damaged, and he couldn't do a simple choice. So why is this? So this is quite, in a way, this is quite clear to nowadays cognitive science. On the other hand, at that time, decision making was seen as an abstract, rational process, following certain procedures and rules and so forth, which in fact it's not. And if you look now, look at the decision making research now, there is a lot of talk about emotions and decision making and so on. So the second thing that's important is that, okay, embodied mind and emotions and decision making, how does this relate? So this is very strongly related. This is directly related, because emotions according to Damasio and a lot of other scientists, are not yet another a third system that is an extra system to body or cognition, but emotions are essentially, or in their core at least, very, very bodily processes. The hormonal changes, the physiological changes, visceral changes. This is really what creates and is constitutive of emotions. So emotions are very, very bodily in this case, are seen as bodily. Body regulation is a big part of emotions, for example. You can look at, just a second, you can, Becerra, Damasio, and colleagues have a great study on certain choice under uncertainty about comparing patients with such a damage to normal persons or persons with undamaged brains, and it clearly shows that the damage in such areas impairs decision making a lot. So the mind is embodied, but what does it mean? Well, so I tried here on this slide in these 3 points condense the most important, let's say, theoretical tenets of the embodied mind view of the human mind. Of course, you will find lots of chaos around what is embodied mind in the literature, but let's ignore this for now. So one of the theses is that the environment, the body, and the nervous system are tightly coupled. They're not separate systems, really. The second tenet, the second proposition is that cognition is not meant for abstract processing of information, but it is meant, designed, I mean, it's not really designed, but designed for action. And the second thing, the third thing that is important is that the usual cognitivist perspective was that there you see a picture, you take it as it is out there, you represent it, you kind of store it in your memory or whatever, and then you can do something with it. So it is not the world we represent as it is, if we at all talk about representations, but if we talk about representations, we mostly, let's say, create memories, I'm simplifying now, of our own actions, of our own interactions with the environment with which we act, but not about the environment as it is. And maybe this is, you can remember this for the next webinar. And the story here is that there is no essential divide between higher and lower cognitive functions or between mind and body. Of course, we can talk about mind and body and so on and conceptual as it is, but it makes less and less sense as we go into the embodied cognition. So now I want to give you a couple of examples of the claim that the perception is embodied. And one of the, I will make it short here. And one of the questions, one of the easy questions one can set and try to find an explanation of is how does a baseball fielder, so the person that is going to catch a ball, how does a baseball fielder catch a ball? And it's a simple question, right? But the answer is not that simple. And the classical account would say, well, that's easy. I perceive, speed of the ball, wind, and so forth. Then my mind calculates, or my brain calculates. So there is calculation. I thus run and then catch the ball. A very expensive computationally and energetically process. On the other hand, we can also ask ourselves, well, but is there really, does really there have to be, because, if you want to calculate the wind and the speed of the ball and how the other baseball player hit it and all sorts of things, and then to catch it, really reliably, as baseball fielders do many times, that's an expensive process. It can't, the brain is not, it's crazy if you do this. It will take forever, for example. But why do you really need all this information processing and representation? Well, there's another option. This is option 3. So you solve this problem without representing all these factors and the ball and where it is and how predictions and so on, and by very little computation, if at all. But you've solved this problem by vision and movement. So what is possible, and there is some evidence supporting this, is that the baseball fielder runs on a curved line in such a way to keep the ball's trajectory through the visual field at constant speed, visually stationary on the retina. And it is just what the baseball fielder is doing here, it's kind of perceiving and acting in a way that enables him or her to catch the ball. And you don't need to compute stuff at all or very little. So, I mean, there is evidence supporting this, so I will not go into this. But I will present to you one quite interesting study that I think it's a good example of the fact or the claim that perception cannot be detached from action. So, in this study, Bruder et al. Were interested in how infants, people learn speech perception. So their subjects were pre-verbal 6-month-old infants that listened to non-native speech sounds, so they did not know these speech sounds. And one group just listened to these speech sounds, the other had teething toys that constrained their movement and positioning of infants' tongues. And they were both listening to these speech sounds, and after that they checked whether they can recognize these speech sounds, so whether they learned to perceive them, to remember them. What happened is a very interesting and a very embodied finding comes out of this, is that if you prevent relevant motor actions when listening to speech sounds, infants did not learn to recognize these speech sounds. So basically, what this shows is that perception is not, a separate system from action, from motoric movement. So you need to be able to move. You need to move, to act in order to be able to perceive. And this is the lesson, one of the lessons of the relation between perception and action. And this is again von Förster's dictum that if you want to see, learn how to act, and that the standard view that the brain picks out the information from the environment and puts them in the head somehow, and then it creates an experience, that this is a false. So the experience, the feeling, emerges out of the interaction, and you can't of the interaction between perception and action, thinking and body and so forth, and you can't dismiss this. If you dismiss this, you don't understand what happens in the human mind. And well, this is a little bit of a joke. Probably only those that have children or know little children well will understand. But toddlers are very naughty sometimes. Very little babies, they're just throwing toys all around and making gray hair to parents, and parents become angry, and how can they be so naughty? But the next time you see a toddler, think about it, that maybe they're just learning how to see or perceive by throwing things, and you might not get too angry about it. So of course, perception, one might argue, was traditionally not part of interest, really, of classical cognitive science. So what about thinking processes, or processes that that classical cog sci was kind of labeling higher cognitive processing? So here I just want to repeat this. So decision making is quite embodied. It is not purely rational. It is not a purely cognitive function. So it is not rational, it is not a purely cognitive function. And emotions are essential to our choices. Secondly, emotions are not another separate extra bodily system. They're very much ingrained into our body. They are bodily. And the lesson here is that body, emotions, and cognitions are very tightly coupled. I just wanted to repeat this. And I will not go into this. Mareike, I guess, knows much more on this than me. But there are some emerging ideas in neurosciences where looking at the networks of the brain and the connectivity of the brain and so on tells you, at least indirectly, that emotions and cognition should not really be a separate conceptualized as separate entities in different brain regions, but what you should look like is the connectivity of different brain regions. So this is just a graph from this paper, but let's not go deeper into this. So embodied thinking. So language is a process, is a phenomena that is very much related to thinking. And you know, the cognitive science has dealt with the question of, for example, with a hard question, a hard problem of where do concepts get their meaning? You know, concepts related to love, concepts related to ideas, argumentation, and so forth. So you might have heard of George Lakoff and Mark Johnson, and in their really beautiful book, Metaphors We Live By, they have all sorts of different metaphors we use to address various very abstract, to express various very abstract concepts. So for example, love, right? We talk about love as a journey, they say, for example. So we head off together, we travel the same path, we take wrong turns, and so forth. We use spatial concepts a lot to anchor our abstract ideas, concepts. So we have control over somebody, we say down with him, and so forth. And there are so many examples that are interesting in their book. So I picked a little bit some that seemed interesting. And for example, when we talk about argumentation, we really use the metaphors of war a lot. The metaphor that, well, they claim this, of battle. So for example, he attacked every weak point in my argument. So his criticisms were right on target. Or when we talk about ideas, it's hard to get an idea across to him. The meaning is right there in the words. His words carry little meaning. So there are really a lot of abstract concepts are really, in a way, very embodied, are metaphorically embodied in a way. So what they claim, and what others would say, that, well, many concepts and abstract concepts as well, that constitute abstract thinking, you know, if you wish, get their meaning in embodied physical experience. And this is another indirect showcase for the claim that, well, language and thinking are very embodied. You know, we understand our thoughts and thoughts of others. Not only we emotionally kind of react to them maybe and so forth, but we also understand this through our embodied experience and maybe our histories, our history of embodied experience. And now I promise just 2 or 3 more slides, and then I will finish. So I will not explain these studies because we don't have time, but there is a lot of research hinting that, for example, emotions are very important for deductive reasoning. Studies showing, for example, that, and this is a rather recent study that looks at the neural correlates of maintaining, in this case political, beliefs in the face of counter evidence. So, for example, in this study, they found that there were participants who changed their mind more, and participants who changed their mind less when faced with counter evidence. And in this study, they found out that participants who changed their mind more showed less bold signal. It was an fMRI study in the insula and the amygdala when evaluating counter evidence. Insula, amygdala are very critical emotional, you know, areas, so to say, in the brain, if we term them like this. So basically, what they find out is that, you know, we have a belief, and there is counter evidence to this belief presented to us, and this in classically would be seen as a rational process. That's the logical structure, thus I will not believe this, or, you know, but of course this is not like this. So there is a lot of emotional processing, and this influences how we are faced with how we accept counter evidence and so forth. So, and emotions, as I said, are very bodily processes. So this is one way of showing that thinking is embodied, let's say. So, to conclude, the embodied mind generally would show that there is no essential divide between higher and lower cognitive functions, between mind and body, basically. So, mind is embodied, so there is no mind and body. You know, you cannot pick out a mind out of a part of a body, basically. So this is not saying that the fingernail includes a mind, of course. So this should be clear. But and another lesson to learn is that if we are to understand the human mind, we need to look at the whole brain-body environment, physical and social, as a system. If we are to understand the human mind, you can't just take it. You can of course take it apart and look at different aspects and so on. But you need to consider the whole such system to get really crucial aspects of it as well. So, you know, to finish this off, in the context of researching thinking processes, we need to go away from the rational content of thinking, of the conceptualization of the thinking, as you know, it's content, it's rational process and so on. And we should kind of try to go and point towards the lived experience, the embodied lived experience as well of thinking processes.